Spdf notation and the periodic table. Is there a relationship between electronic structures of elements using Spdf and periodic table? The answer is yes. Actually, we learned the other day that we can use the electronic structure of elements in the main shell, that is KLOM, to determine the group and the period to which an element belongs in the periodic table. Don't forget that the periodic table is where every element is arranged. Yes. Where we have groups and the period. We can as well use electronic structure in the subshell, that is SPDF notation, to determine the group and the period to which an element belongs. Let us see how it goes. For example, if we are asked to write electronic structure of phosphorus is 15. Don't forget the sequence, Avogadro principle, 1s2, 2s2, 2p6, 3s2, 3p. Let me count before I write another. 2 plus 2, 4, 10, 12. That is 3p, 3. This is the electronic structure of phosphorus using SPDF. Yes, since these two are the same, I am collecting the last two. That is to say, this one is 3, this one is 3. So I'm collecting the last two. If I want to determine the group of phosphorus, I'm going to add these two things, 2 plus 3, which give me 5, which means phosphorus belongs to group what? 5. And the period, I am taking only this one as period. Period 3. That is to say that phosphorus belongs to group 5, period 3. Don't forget, I took the last two because they have something in common. Here is 3 and here is 3. That is why I'm taking the last one. Let us see another example. Calcium. Calcium is 20. Remember, 1s2, 2s2, 2p6, 3s2. I believe you are following because we did it in our last video. 3p6, 4s2. Let me count. Don't forget the sequence. Electrons will enter into all these degenerate orbitals or all these orbitals with the one that has the lowest energy. 1s, 2s, 2p, 3s, 3p, and the rest of them. If you count this enough, it is 20. I will take the last one. Why am I not taking the last two? Because the last two has nothing in common. This one is 3 and this one is 4. 3 and 4, they are not alike. The first example I collected the last two is because this is 3 and this is 3. They have something in common. That was why I collected the last two. But here, 3 and the 4, they don't have anything in common. So now, this up one will tell me the group number, group 2, and this down one will tell me the period to which it belongs to, which is the period was 4. So cows will belong to group 2, period 4. Further example, consider that of nitrogen 7, 1s2, 2s2, 2p, 7, 2 plus 2, 4. It's remaining how many now? 3. That is 7. If you add all this in there, it will give you 7. Now, I'm taking the last two. You know why? Because this one is 2 and this one is 2. They have something in common. So I am combining these two things. 2 plus 3 gives me 5, which means nitrogen belongs to group 5, while it belongs to period 2. You can as well give more examples of how you can relate the electronic structure of an element with periodic table. You can as well use it to know the group and the period to which it belongs to. See you in the next video.